Welcome all, and we are working on approximating square roots today. So, first thing is to determine which two perfect squares the number inside the square root falls between. So in this case, that would be between the square roots of 25 and 36. So that is the first thing we're going to determine. Now, it's going to help to know whether 28, when we make our guess later, is that closer to the 25 end, the 36 end, the middle. It helps you estimate it easier. You don't always have to write these out, but it can be helpful. All right, the second step, determine which two numbers the value of the square root falls between. In other words, the square root of 25 is 5, the square root of 36 is 6. So the value of the square root of 28 is between the numbers 5 and 6. It can't be lower than 5.0. It can't be bigger than 6.0. So now let's look at the next step. Approximate the value of the square root to one decimal place. Not like 5.26, but 5.2, for example. Well, when I look at this, it's halfway, let's see. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 6 is halfway. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that would be halfway. This is closer to the lower end, but about the middle of the lower end. So I'm going to guess 5 point something. Now that something to you might be 5.2, 5.3, 5.4. I'm going to guess 5.3. Let's see how close we are. So, make a guess. The next step is to square the guess and determine, it should say if, not it. If the result is above or below the value in the original problem. In this case, that would be 28. So we're trying to find, like 5 squared is 25, 6 squared is 36. We're trying to find what squared gives us 28. So we're going to guess 5.3. So we're going to square 5.3 and see what it comes out to. Now remember, on the MCAS test, they are not going to let you do this in the calculator section. This will be in the non-calculator section. So you want to make sure that you are able to do this without a calculator. 3 times 3 is 9, 3 times 5 is 15, 0. 5 times 3 is 15, carry the 1. 5 times 5 is 25, plus 1 is 26, add it up. 9, 10, so that makes it 8, and 2. So now there are 2 places after the decimal. So I am going to start all the way to the right and move it 2 places into the left, 28.09. Now that is above the number I was shooting for, which was 28. So anytime you get one that's above, if the value from A is above, go down by 1, not one whole number, but by 1/10. And repeat step 4. If it's below, go up by 1 and repeat step 4. And we're going to do that until we get one that's on either side and only 1/10 apart for the guess. Okay, so this was above, so I need to go down to 5.2. That's from 0.3 to 0.2, that's 1/10 down. I do this multiplication. 2 times 2 is 4. 2 times 5 is 10. 0, I use that up. 5 times 2 is 10. Carry the 1. 25 and 1 is 26. Add it up. 4, 0, 7, 2. Move the decimal over 2 places, and it is 27.04. Now I have 28.09, which is above, and 27.04 is below. So, and they're only a tenth apart. That's what we want. Now, find the difference between your answers and the number you want, the 28 in this case, and determine which is closer. The closer one is the guess that you had that was closer is your answer. So if I go back up here, I am going to subtract with 28. Now, the bigger number, 28.09, is going to be on top in the subtraction. And I'll throw a couple of decimal zeros in there. And I get 90.0. So 0.09. On the other side, I get 28.00. That's the one I'm looking for. And this is smaller, 27.04. I subtract. Remember, when you're subtracting, you can't subtract 0 from 4 because 0 is smaller, so I have to borrow 7. The 1 goes here, I have to borrow again, 9, 1. 10 minus 4 is 6, 9 minus 0 is 9, decimal point, 7 minus 7, 0, 2 minus 2 is 0. So I get 0.96. Now, of these two, the closer one is 0.09. This is much bigger. That's like comparing 96 to 9. Okay? So this is closer. Now, that does not mean that that's my answer. It doesn't mean that 28.09 is my answer. No, it means that 5.3 is my answer. And that is how you approximate square roots. Now, there are other methods out there for approximating square roots. There's the half method, that you go to the middle, 5.5, and if it's above, great. If it's below, you cut the difference in half and do it again, like 5.25 times 5.25, and you keep repeating. I don't think that that is as quick a process as this is, assuming you have a good guess. If you're poor at guessing, the other method might be better, but I think it's more confusing for students that struggle in math. So I think this is a better process in general. All right, so hopefully you were able to see all of these. I'll pause, so you can pause the video if you need to write down anything. I'll pause again. And I'll pause one, well, let me see, I'll leave it there. And then I'll move it to there. All right, so hopefully you got everything written down, pausing the video. Here's our next example. Now, if you need it, make yourself a little chart like this of the numbers 1 through 12. I know this only goes to 8 that you can see, but it goes all the way to 12. And then square each of those. You're trying to find, where does 8 fall between in the squares? Well, if I look at this list, 8 is between 4 and 9. So it's between square root of 9 and square root of 4. And of course, 4 square rooted is 2 and 9 square rooted is 3. So this is between 2 and 3. Now, if you think about it, is 8 closer to 4 or 9? Well, closer to 9. Is it more towards the middle or towards the end when it's closer to 9? Well, it's way closer to the end. So you might start with 2, remember, 0.9. Or you could even start with 3.0. Let's start with 2.9. So we multiply. 9 times 9 is 81, 8. 9 times 2 is 18, and 8 is 26, 0. 2 times 9 is 18, 8. Carry the 1. 2 times 2 is 4, plus 1 is 5. Add it up. 1, 14, 8. Decimal point is here. I've moved in 2 places. That is above so I want to go down 1. Now 1 further down would be 2.8. And I'm going to try that. 8 times 8 is 64, 6. 8 times 2 is 16, and 6 is 22, 0. 2 times 8 is 16, carry the 1. 2 times 2 is 4, plus 1 is 5. Add it up. 4, 8, 7.84, below. Again, we want to see the difference between 8, in this case, and these two end results. 8.41 minus 8.00 turns out to be 0.41, or 0.4, not 0, 1. And over here, 8.00 minus 7.84. I have to borrow 7, 9. All right, so 6, 1.0. Well, 41 versus 16, closer here. So therefore, our answer is the 2.8. Remember, the purpose of this is not to use your calculator. It is to do it without your calculator. Anyone can go, oh, square root button 8 and get an approximation. The point here is to be able to do that without your calculator. Because you're going to be asked that kind of question on the MCAS test in in junior high and in high school. All right, let's go to the next example. Square root of 54. So to do this one, I'd like you to give it a try since I've done 2 and see if you can do it on your own. And when you're done, you can work with me on that, and I will do the example out. Okay, pause it. Unpaused when you're done. Here we go. All right, so square root of 49, square root of 64. 54 is closer to 49 than 64, but it is not tremendously closer. It's still more towards the middle, but towards the lower end middle. So this is only 5 different, and this is 10 different. So maybe, remember this is 7 and this is 8. So 7.3? 9, 21, 21, 49, 50, 51. Add it up. 9, 2, 3, 5 decimal point. That's below. Now you could put B for your own purposes, but no, when you're on a test or quiz, you should say below. Since 7.3 is below, let's go up 1 to 7.4 and see how that works out. 16, 28, 29, 0. 7 times 4 is 28, 2, and 51, 49 plus 2. Add them up, 6, 17, 4, 5, decimal point. 54.76, that is above. All right, so now let's test it out here. See which one's closer. 54 is bigger than 53.29. And when I subtract, I want another color here, 3. All right, so 17.0. Here, let's see, 54.76 minus 54.00, 0.76. Wow, these two are really close. 0.71 and 0.76. That's super close. So we could have guessed either 7.4 or 7.3 originally and been very good at guessing. But since this one's just a little bit closer, because it's a smaller number, 7.3 is the best answer here. All right, let's see our next examples. I'd like you to give both of these a try. When you're done working on them, unpause the video and see how you do. 12 is between square root of 9 and square root of 16. 80 is between square root of 81 and square root of 64. Now we know square root of 9 is 3 and square root of 16 is 4. Square root of 64 is 8. Square root of 81 is 9. All right. 12 is 3 above 9 and 4 below 16. That's really close to the middle. So I'm going to guess 3.5. Well, 5 times 5 is 25. 15, 17, 0. 3 times 5 is 15. Carry the 1, 9, 10. Add it up. 5, 12, 2, 1 decimal point. 12.25. That's pretty close to 12. It's above, however. So I want my next guess to go down by 1 to 3.4. 4 times 4 is 16. 12, 13, 0, 12, 3, 9, 10. Add it up. 6, 5, 1, 1 decimal. 11.56 is below. And then I have to find which one's closer. 12.25 minus 12.00. 0.25 is my value there. And 12.00 minus 11.56. Now, if you're good with this, you know that's like 44. But just to be on the safe side, 10 minus 6 is 4, 9 minus 5 is 4, 0. Sure enough, this one is closer. So my answer is going to be 3.5. In my other example, '81 is way closer to 9 than it is to 8. I mean, almost touching it. So maybe I start with 8.9. I'm never going to go more than 9.0. But let's see 8.9. 9 times 9 is 81. 9 times 8 is 72, and 8 is 80. 0. 8 times 9 is 72. 64 and 7, 81. Wow, what did I do wrong? 64, 71, and 71. Much better. Helps when you can do mental math. 1, 2, 9, 7 decimals, 79.2. Wow. Hate it when I make silly mistakes. All right, and then I gotta go up to 9.0. I know that's 81.0. This is below, this is above, and let's finish it off. Remember, we're trying to compare it to 80. 80 minus 79.21. Borrow 79, 9, there we go. 97 decimal point 0. All right. And with the other one, 81 minus 80 is 1.00. This one is closer. So my final answer here is 8.9. Now there are situations where the 9.0 might have been the better choice. But typically you have to get higher in numbers for it to go to that extreme. All right, so 8.9. Try the problems in the homework and hopefully you do well. Have a great day.